Hello there. In this video, we're going to cover another QPython tutorial. And really, I'm looping back to a deficiency with one of the earlier tutorials, a couple of them actually, where I did not cover the case of rerouting all that sufficiently because the routing behaviors that I had chosen would always set the routing to just leave the system, and so you wouldn't be able to see for yourself that it actually reroutes the customers to another class. So to make up for that, I just wanted to do a quick example where we rectify that. Here we've only gone down to 2 nodes here with these service schedulings, one that is non-preemptive and the other one that is preemptive for the schedules, but the schedules are otherwise the same. We have 2 priority classes and routing behavior for each of them defined at each node. Okay, so what I have changed here from last time is just that there is actually going to be some expected flow. Let's try running this and take a look at, I guess you could kind of say, the journey of the customer, or if they were patients, kind of the patient journey, as it were, by just focusing on one individual. I happened to pick the individual whose ID number is 124 under the seed, but it shouldn't actually be that special. I could have picked other ones to show. So I've selected out some things like the record type. So what's going on here is this individual first had their service interrupted at node 2, where they arrived into the system in the first place, and they were waiting for 89 units of time after they arrived at the arrival date of 420 units of time, and then they left at 510. And this 510 is actually when their service was interrupted and they left the node. It's not when they actually received service, because this is an interrupted service record. So after they were kicked out of node 2, they went to node 1, and they got a successful service. At that node, while waiting, they waited 190 units of time. You can see that their arrival date was the same as their exit date. In other words, there's kind of instant transferal from where they were kicked out at one node and arrived at another one. If you wanted to do some additional waiting, you could create another node where they just flow through and spend some time in a different state. But here they're just instantly transferred. So they finally received their service of 706 units of time at the second service, which is actually the node 1 service. So potentially, depending on how you play with the numbers, you don't necessarily get just one interrupted service for an individual. That really they could have their service fail multiple times as they cycle through the system. It just depends on a combination of the network topology, that is the structure of the network, loosely speaking, and also what the specific numbers are in terms of the rates of change and how many customer classes and what the schedules actually are. It depends on a lot of finer details for how the history plays out for a particular customer, as well as the pseudo-random behavior that we're not trying to control here. Well, we've set a seed, but we're not trying to control the details of the system in general. So hopefully that's useful to just kind of clarify the idea with the rerouting, is that they really do immediately, when they're kicked out, when they're interrupted in their service, they are kicked out to another node where they basically start again at that new node. Hopefully that's helpful and improves your simulations, and I'll catch you in the next one. Take care.